So now that we've defined expected value and we've talked about utility functions and sort of how utility functions, they're increasing in income, but they are the marginal utility. They're decreasing. The marginal utility is decreasing in income, which again, that means that my first dollar matters a lot more to me than my going from $0 to $1 is much more important than going from 99 to $100. Which is much more important than going from a million to $1,000,001, right? If you have $1,000,000, picking up a $1 bill on the sidewalk might not even be the worth the effort to bend down and pick it up, right? If you're Elon Musk or Bill Gates, right? You earn more money in the time. You earn more money per second than reaching down to pick up a $1 bill off the ground would get you, right? Now that we've talked about expected utility now that we've talked about utility and expected value, let's talk about risk aversion and expected utility. Risk aversion. So let's consider two lotteries, right? So you can. I give each of you a choice. This is purely hypothetical, by the way. I am not giving any of you money in real life. Let's be clear. We have Lottery A and Lottery B. And Lottery A says you win $500. That's a money sign, by the way. $500 with prob. We'll do 1/2. So there's a 50% chance you win $500. $0 with prob 1/2, right? So there's a 50% chance you win $500 and a 50% chance you win $0. And Lottery B, let me make that B a little prettier. That is prettier. And this is, you get $250 with prob 1, right? So stop right now and ask yourself, which one would you prefer? Do you want a 50% chance to win $500 or a guaranteed chance to win $250, right? Because you'll notice the expected value of A, right, is going to be 1/2 times 500 plus 1/2 times 0, right? That's 250, right? And again, this is P times A1 plus P plus 1 minus P times A2, where in this case, P is 1/2 and A1 is $500 and A2 is 0. And the expected value of B is just 1 times 250 is equal to 250, right? So these two lotteries have the same expected payoff. However, one there's a 50% chance you get $500 and a 50% chance you get nothing. And the second, there's a guaranteed, you're guaranteed to get $250, right? Most people would choose, think about which you would choose for a second. Most people would choose Lottery B, right? They prefer the guaranteed income to the chance of a really high income. And maybe you're different, right? Maybe you're like, there's something I really want to buy with $500. Let's say, replace the $500. Let's say it's 2 million and 1 million, right? So Lottery A, there's a 50% chance you win $2 million and a 50% chance you get nothing. And Lottery B says you get $1 million no matter what. I think my guess is everybody in the classroom would take $1 million, a guaranteed $1 million, over a 50% chance of $2 million and a 50% chance of no money at all, right? $1 million is a lot of money. That's life transforming. And the difference between $1 and $2 million just, it matters. I can do more stuff, but it's not as big as the difference between 0 and $1 million, right? So people who choose Lottery B over Lottery A are risk averse, right? They prefer the guaranteed money over over the risky money, even when the risky money, even when on average the risky lottery and the safe lottery pay out the same, right? They have a preference for the safe lottery. So how do we think about, so under expected value, right? These two have the same payoff, right? But clearly, they don't have the same expected utility, right? Because most people are choosing B over A. How do we think about expected utility, right? So we're going to think about people in economics, we think about people evaluating lotteries and risk through the lens of expected utility, not expected value, right? So expected utility. The expected utility of a random payoff X, which is we're going to note as the expected value of U of X, is the sum of utility across all possible values of X weighted by the probability X takes on those values. So, if the possible outcomes are X is in X1, X2, Xn, right? So if X can take on any of those values, right, X1 to Xn, and the probabilities that X1 occurs are P1, the probabilities that X2 occurs are in P2, probability that Pn occurs is Pn, so Pi equals prob X equals Xi. Then the expected value of the expected utility of X, the expected utility of X is equal to P1 times U X1 plus P2 times U X2 plus plus Pn times U Xn, which in turn is equal to sum I equals 1 to n. This is just using sum notation, right? These two lines say the same thing. U of Xi. So one note about expected utility is that if you treat U of X as a random variable, expected utility is the expected value of U of X, right? Which is why we denote it like this. So let's talk about how does this lottery, right, lottery A and B, how do they look under the expected utility framework, right? Because we showed they have the same expected value, right? So E U A is equal to P, right? P is the odds I win the lottery here, times U of 500 plus 1 minus P, sorry, U of A1, right? P1 A1 plus P2, which is also, right, so P1 and P2 are both 50% here, times U of A2, right, which is equal to 1/2 times U of 500 plus 1/2 U of 0. And then we have the expected value of lottery B is equal to P1 U of B1. Now notice there is no second option for right here P1B, right? I suppose we can P1A, P2A, right? Where this is the odds that B is B takes on value B1. Now B only takes on one value, and that's 250, right? So that's just equal to 1 times U of 250, which is equal to U 250, right? So let's see which of these is greater, right? So we have U of 250, right, is going to be greater than 1/2 times U of 500, right? Because that first $250 is worth more to you. Going from 0 to $250 is worth more to you than going $250 to is worth more to you than going from $0 to from going from $250 to $500, right? So that means that the utility you get from a guaranteed 250 is higher than the utility you get from a 50% chance of $500, right? So this is expected utility. And expected utility predicts that somebody who has decreasing marginal returns to income will pick lottery B. Okay. Now, let's apply this to the situation of getting sick, right? So as a reminder, there's a P% chance we get sick, right? And your payoff in the sick state is IS. Your payoff in the healthy state is IH, right? No, not what I want to do. So what's your expected value of your utility of I given a certain probability of getting sick, right? What's your expected utility given a probability of being sick? Well, it's P times U IS plus 1 minus P times U of IH. And so let's think about this, right? Let's say somebody comes along and says, hey, I'm going to offer you the average of IS, right? So I'm going to offer you a weighted average of IS and IH, right? I'm going to offer you an insurance contract, and that insurance contract, instead of there's a P chance you get IS and a 1 minus P chance you get IH, I'm going to offer you 1 minus P IS plus PIS plus 1 minus PIH, right? Would I take that deal if I have this guaranteed income, right? If I make this my guaranteed income, which notably is the expected value of I, right? So EI, right? So this is what EIP is equal to, right? So let's graph this for a moment. Right, so we're going to draw a graph here. We have U, and then we have I, and then we have our decreasing marginal returns to income here. Let's make it a little more dramatic. Good enough. Okay, and we have, let's see, let's do dashed lines. We have, and okay, let's see if I make that a little straighter. All right, and we have this is IS. This is IH, right? And then we have, this is going to be U of IS. And up here we have, about here we have U of IH, right? And then you'll notice that, let's do a dotted line here. If I draw a straight line connecting these 2 points, right, that it lies below my expected utility line, right? So if somebody offers me, right, let's say somebody says, hey, instead of taking your odds with, so what's my expected utility for a given probability P, right? It's going to be somewhere on this line, right? Because I take a weighted average of these two. So let's say, let's say there's a 25% chance I get sick, right? There's a 25% chance I get sick. That means that's about here. That's about a quarter of the way up, right? Do another dashed line, right? This is going to be the expected, this is my expected income, this is the expected utility of income. This is expected income when P is 0.25, right? This is the expected income when P is 0.25. And you'll notice that dashed. This is going to be my expected utility of income when P is 0.25. And then if there's let's say there's a 75% chance I get sick, it's going to put me about here on the graph or so. And we're, no, not what I want to do. Dashed, right? Right. Solid is going to be this is my expected income when P is 0.25, and then my expected utility of income when P is 0.25 is, that should be dashed. All right, it's going to be this. All right, so E U I 0.75. And sorry, that should be a 0.75. So this is if there's a 75% chance of getting sick. This is my expected utility, right? So you'll notice again my odds, my expected utility when my odds of getting sick are low is higher than my expected utility when my odds of getting sick are high, as is my income, right? So if there's a 75% chance I get sick, my income's down here. That's less than my odds of getting sick if there's only a 25% chance I get sick. So now let's think about what happens if there's a 50% chance I get sick, right? So P equals 0.5, which for the record is the same as 50%, or 1/2, right? Those are all the same number. In that case, right, I'm going to end up, right, if there's a 50% chance I get sick, right, that means the expected value of my income is about here, right, and that's the expected value of I when P is 0.5. So the expected value of my utility is, let me draw a line here because this is important, dashed, it's going to be like roughly there. So that's the expected utility. No, that's not quite right. Let me make that a little smaller and lower. That's the expected utility of I when P is 0.5, right? So let's say somebody comes along and says, Liam, there's a 50% chance you get sick, right? What if I guarantee you, you give me your income no matter what, right? Give me all your income in any state, right? Give me your income no matter what. And in return, I will give you the average of what you would have earned in the healthy and sick payment in sick states, right? So there's a 50% chance you're healthy. There's a 50% chance you're sick. What if instead of that, right, you give me all your income, whether you're healthy or sick, right? And in return, I give you a guarantee I'm going to pay you the average of your healthy and sick incomes, right? Well, what's my, if I'm guaranteed the average of the healthy and sick state, right? So that's the same as being guaranteed the expected value of my income. What's my utility, right? Well, it's actually up here, right? And you may notice that I will accept that bargain because this is the utility. No dashed line there. Because this right here is the utility of the expected value of my income, 0.5. Right? So you may notice the utility of the expected value of my income is higher than the expected utility of my income. Right? And so if somebody offers me, hey, you give whatever, whether you're healthy or sick, you pay me all your money in either state, and I give you the expected value of your income in the healthy and sick state, I will take that deal, right? Because I would rather have the expected value of my income than my expected the expected utility I get from that lottery, right? Because very importantly, EI 0.5 is greater than right? So if somehow I'm able to exchange the lottery of being sick or being healthy for a contract, for example, let's say an insurance contract, I hope you see where we're heading with this. Let's say an insurance company says, we'll give you the expected utility of your income if you give us we give you the expected value of your income in exchange for all the income you earn. I'll take that deal, right? Because the expected value of my income is higher than the utility of the expected value of the income is higher than the expected utility of my income, right? So this gives us a new definition of risk aversion. This is going to give us a definition of risk aversion, right? And so risk aversion, we can define risk aversion in three equivalent ways. So equivalent definitions of risk aversion. And you should be able to think about risk aversion through the lens of each of these definitions. So, definition one. We have U double prime I is less than 0. We have the utility of the expected value of my income is higher than the expected utility of my income. And the individual prefers a certain outcome to an uncertain outcome with the same expected value. Right, so these three are equivalent, right? So we have right. So we have the definition of risk aversion I mentioned at the start, right, and that's that my marginal utility of income is I always prefer more income to less income, but my marginal utility of income is decreasing, so I prefer it's more important for me to go from $0 to $1 than from $1 million to $1,000,001. That's equivalent to saying the expected value of the utility of the expected value of my income is higher than the expected utility I get from my income, which is also the same as saying the individual prefers a certain outcome to an uncertain outcome with the same expected value.